Well, hey everyone, and welcome back. This video is going to be about converting a topographic top-down profile into a two-dimensional cross-sectional diagram of the surface of the area shown. So of course, the first thing you may be asking is, well, how do you convert between a top-down two-dimensional, where the axes are the x and the z, into a two-dimensional diagram where the axes are the x and the y? Well, that's where contour lines come into play, because as I discussed in the last video, hopefully you're familiar with contour lines, but they show different elevations on a topographic profile. So these effectively allow us to, in a sense, convert seamlessly, although it does require a certain area of interest designated on the map. And in this case, our area of interest is through this line, x, y. So we're just giving a two-dimensional cross-sectional diagram of the surface through the line x, y. And this really is something that comes intuitively and pretty easily, but sometimes it's good to just see an example done if you're a bit confused sometimes. Maybe you are working with quite a few numbers, and the different elevations can sometimes mix you up a little bit, so sometimes it's just nice to see someone do it out. And maybe you're one of the people it doesn't come too easily to, but in any case, I'll just be showing how this looks in this video. So the first thing we're going to do is we're going to draw our little cross-sectional, just the outline of it. And the first thing we need to do is label our axes. So the y-axis, in this case, the vertical axis, is going to correspond to our height. Now, the deal with height is we know 0 is our lowest. However, through the line xy, we have to look, if this is 0 here, and this is 50, how many are in between? It looks like it would go 0, 10, 20, 30, 40, 50. You see? So our xy line actually starts here. So really, we don't need to include 0 in this diagram because we never reach it at any point on this line. You can check that too here. If we look at, there should be a lower point in here too. If this is 50 and this is 50, it must have gone down between here. So if we start off at 50 going down, we go down to 40, 30, 20, 10. And then this line here is also 20, I labeled it. So once again, we know that our lowest point is in fact 10. There is no point on this through the line xy at which the elevation is 0. So we'll just put 10 as our lowest point. If we wanted to, we could do 0, but I'm trying to use up all the space here so we don't have any unused space down at the bottom. And the highest point we can determine, well, simply by looking over here. It looks like the highest we get is just over 50, and in here we go 10, 20, 30, 40, 50, 60, and then we go inwards, so we get a little bit above 60, not quite 70 as our highest. So we're going to put 60 not quite at the top, because you have to remember with topographic profiles, even though the contour lines will always be incremented by a certain number, in this case 10 in this example I've drawn, the area between two contour lines will be fluctuating. And to be as accurate as possible, since this is a hill and we're seeing an upward trend, we can assume that it raises slightly above 60. Like it doesn't just plateau suddenly on this little oval shape. That'd be quite strange. But anyways, then we can just fill in the rest of the axis using simply, I'll try to make these as even as possible. Doesn't have to be perfect. This is just an example. You'd probably want to use a ruler or some measuring device. Actually, this is just terrible. This is nowhere near close. You know what? Give me a second. I'm going to use my ruler and try to measure these out. Okay, so if this is Okay, so it's still nowhere near perfect, but whatever, we'll just make do with it. 10, 20, 30, 40, 50, 60. Not sure why that's there. And now we have to work with our horizontal axis, which in this case is the distance across line xy. So we'll start here, go from x to y. 500 meters is about 2¼ inches. There's one. That goes, this is about a foot. So we'll call that 5 times 500 meters, roughly. Once again, not trying to be perfectly exact here. So we'll call that this entire thing 2,500 meters. So we'll start here, 0 meters, and then we get up to 2,500 at point Y. Okay, now the rest of it is just moving along the line and noting any elevation changes you see. So we know right off the bat, starting at point X, we are on this contour line, which is at 10. So we can start right there. Now we touch the 20 contour line. Actually, you know what, I'm going to divide this one up too into 5 portions. We'll call that 500, 1,000, 1,500, 2,000. Nowhere near perfect. If you're doing this not as a silly little example, then you should have measurements much more even than this. But this will do just for the example. So we can then measure the distance between the 10 and the 20, and it appears to be about 1 inch, or about half of our 500 meters. So we'll say it reaches 20 at about 250 meters, maybe about right there. Okay, so we've got another dot there. Then it reaches 30 pretty quickly. You can see this is a steeply sloping surface right here. That's about 1/4 of an inch, or about 1/8 of 500, which is about, oh geez, 70-ish. Between 60 and 70. So we'll say that that gets up to around 300, so maybe around right there. We get up to 30. And then if we look at the distance between 30 and 40 once again, that is around the same, so we'll just go, and we're probably just before 500 here by the time we reach 40. The next one, that's about ½ an inch, so that's going to be about 125 feet later, and meters, excuse me. We're using inches and meters, yes. I like to use multiple systems at the same time. Keeps your brain on edge, you know. Where was I? Yes, 125 meters in this direction. That's when we meet 500. So maybe we're about right there now. Excuse me. That's when we meet the 50 meter high mark. Then looks like about another 1/4 inch after that. Yeah, roughly. About another 1/4 inch later, we meet the 60 mark. So maybe we're about 60 or 70 meters later, right there. So you can see this is where we kind of peak our mountain, and you can see it's very steeply sloping for the most part at this point. And then about another inch later, so that's about 250 meters. We'll say that gets us pretty close to 1,000. We get right there. Man, I just have to say it. This is working out worse than it should, just because once again my scale is so poorly drawn. But you'll get the general idea. And then it's about ½ inch to the next one, so that gets us just over. And you'll notice it's going back down to 50. after going to 60 and back to 60, it actually goes back down to the 50 contour line we drew right here. So that's another 125 meters later. It gets us a bit over 1,000 meters away from point X. Now we're going down very steeply, and just by eyeballing, these all appear to be roughly 1/4 of an inch. So I'm just going to say that we go to 40, about 60, 70 meters later, pretty small distance between them. 30, roughly the same thing. And then 20, which is right 50, 40, 30, 20. 20 is about the same thing, and 10 is even smaller, it seems. So we'll go something like that, and then maybe something like that. Very steeply declining. But then we actually go back up to 20. When we reach this line here, we go from 10 to 20. We're going back up the side of a mountain, and that appears to be about 1/2 inch, so slightly gentler slope. It'll be about, about 250 meters later, so maybe we're right here now. We're back up to 20. And then between 20 and 30, it's about the same thing. We'll put that guy right there. And then you can see between the 30 and the 40 here, we have a huge gap. That is roughly 500 meters. And just as I predicted, I am going off the map here. But we'll try to squeeze this in. Put our 40 right there, and then our 50 would be, looks like another roughly 500 meters, so it would be way over there. But you can get the idea just by connecting the dots and then looking at the slope, what kind of surface we're dealing with. Very steep incline and decline at first, and then a much more gradual one that you can see here, much more gentler slope. And if we just think about it logically, that's basically what we can see on our topographic profile. The contour lines are very closely packed together, so we'd imagine a very steeply inclining hill, since we know it goes from 0 to 50 and up to above 60 at its maximum. Then starts to go downward, that's what we see here, very steep decline, and then starts a much more gradual shift up on another hill, which is what we see here. And that's about it for drawing a a cross-sectional diagram of the surface from a topographic profile. You'll see what I did here between the 60, after 60, right about there. I did a little, just kind of did something so that it doesn't look like a flat top once again, because in between the two 60s, we're not staying at 60, we're likely raising a little bit, but not enough to get us up to the 70 mark. So we just get this little bump here, the top of the mountain, or the highest point rather on the XY line. And then we start our decrease.